Now that we have definite integrals in our tool belt, we can start to take a look at some of the past free response questions from the AP test. And the reason we've had to put it off is so many of these free response questions draw on content from the entire course. So today I passed out this free response problem number 134. Happens to be on the no calculator section of the AP test. And this will give us an idea of how some of these problems are designed and how they draw off several concepts from our course. So I first want to read through the problem with you and talk about what we're looking at, and then on the slides in this video we'll give some hints for each of the parts A through D of this problem. I think it's important as you begin these problems to really take a look at any graphics that they have, like the graph of the function here, and then also read all of the problems. Read everything over before you dive into one particular part. So I'm going to do that here, and then we'll break them down part by part. The figure above shows the graph of f prime, the derivative of a twice differentiable function f on a closed interval from 0 to 8. The graph of f prime has horizontal tangent lines at x equals 1, x equals 3, and x equals 5. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure. The function f is defined for all real numbers and satisfies f of 8 equals 4. And then we have four parts. For A, find all values of x on the open interval, 0 less than x less than 8, for which the function f has a local minimum. Justify your answer. That means show some math. Or write an explanation. Letter B, determine the absolute minimum value of a function on the closed interval 0, 8, and justify your answer. Letter C, on what open intervals contained in 0, 8 is the graph of f both concave down and increasing? And then letter D, the function g is defined by g of x equals f of x cubed. If f of 3 equals negative 5 over 2, find the slope of the line tangent to the graph of g at x equals 3. So that's the entire free response problem. And remember, these are probably going to take you 15 minutes or so. So now that we've read through it, we want to break it down a little more and really talk about what we have here. The first thing I want to point out to you is that this graph is the graph of f prime. So this graph represents the derivative of f. In other words, this thing is all the slopes of f. So this is f prime. I'm just going to write it bigger here so we don't forget. The graph is f prime. If we're ever asked about the function f, that is not shown in the graph, right? The only thing we know for sure about f right now is that f of 8 is 4. So the point 8 comma 4 is on the function f. And that is not shown here anywhere because this isn't the graph of f. This is the graph of f prime. Okay, so we've talked about some of the information, and then the other thing I guess I'll point out is that they mention here that this f prime has horizontal tangents at 1, 3, and 5. Okay. That may or may not be important, but remember, those are places on the derivative, not the function itself. Okay, so each slide I'm going to talk about a different part, and I'm going to focus on part A for this slide and just give a few hints. In part A, we're asked to find all the values of x on the interval from 0 to 8, the open interval. So 0 and 8 are not part of these answers. We're just looking for some x values on the interior where the function has a local minimum. And by function, I mean f itself. Remember, f is not pictured, but we have to tell something about f by studying its derivative. So my hint to you is this. When we make a sign diagram, right, we plot out different critical points, and then we check the values of the first derivative. And so what we do is when we find a positive first derivative on a particular interval, we indicate that that part is increasing. And when we find a negative first derivative, we indicate that that part is decreasing, and so on. And then when we analyze the sign diagram, we find out that when the function goes from, when the derivative, f prime, remember we're doing a sign diagram on f prime, when the derivative goes from positive to negative, we determine that that is a local max. And when the derivative goes from negative to positive, we consider that a local min. Well, we just happen to have a graph of the derivative here in the picture, so we ought to be able to locate where that derivative goes from negative to positive. In other words, where it crosses from below the x-axis to above the x-axis. So my hint for you on letter A is look for those places where this graph goes from below the x-axis to above the x-axis. And then you'll find your x-coordinate, and that will be the answer to letter A. If it says justify your answer, you say, hey, I looked on the graph and the derivative goes from negative to positive there. And that's why I'm saying this is a local minimum. Okay, let's get a new slide and we'll talk about letter B. So hopefully you finished off letter A and you found that point where the first derivative, the graph, crosses from negative to positive. Now we're going to look at letter B, and in letter B we're asked to determine the absolute minimum value of f. Remember, this is about f, not this graph. This graph is f prime. We're trying to find the absolute minimum value of f on the closed interval 0, 8. Well, remember we have a theorem called the extreme value theorem. We called it the EVT for short, right? The extreme value theorem. And it addresses this exact issue. I got to spell this right. Theorem. So we're going to apply the extreme value theorem. We have a continuous function, and by the way, I know it's continuous because it's twice differentiable. We have a continuous function on a closed interval, so we know there is going to be an absolute min and an absolute max. The theorem tells us that, and we know where to look for these suckers. We look at endpoints and critical points. Okay, so from the last problem, you found a critical point. I don't want to give away the whole story here, but use that answer, right? So the guy from letter A, I'll just call that x equals A. That is one of our points that we have to pay attention to, the answer from the last problem. We also have our endpoints, so we also need to check x equals 0, and we have x equals 8 for the other endpoint. Now, f of 8, I already know. The y value there is 4. So all I have to do is find the y values for the point from the last slide that we found and for 0. So I'm going to focus on 0 in this problem, and then you'll take your other point and do the same thing. So how in the world do we figure out what f of 0 is? Well, when we have the graph of a derivative, the way we find out function values is using accumulation. So please remember from our accumulation discussion that the way you find function values, f of x, is you start with the initial value. So we typically call that f of a, but since I know that 8 is the initial value, I'm going to say f of 8. And then we add on the accumulated change from 8 to whatever x value we're interested in. In fact, let me make my x's red in both situations here just to make this look a little more intuitive. Of the derivative, right? We're going to integrate the derivative f prime of t dt. So we're going to do the definite integral from 8 to x. So for example, if I want to do f of 0, and I'll make that 0 red, I'm going to set that equal to 4, because f of 8 is 4, plus the definite integral from 8 to 0, and I know that looks weird, of f prime of t dt. And if those numbers there concern you, you can always switch the 0 and the 8 and then make this a negative. So we'll just do 4 minus the integral from 0 to 8. I think that's a better way to address that. Okay, so definite integrals aren't a big deal usually. This one's a big deal because we have no idea what f of t is. But we do know the areas. So remember that the definite integral of a function is just the area between the curve and the x-axis. So they've given us these areas. And what we're going to essentially do is just add those up. Now, be careful of this bad boy right here. This a equals 3 is below the x-axis. So when you add those up, that's going to be a negative. So you'll compute this accumulated area here. Remember, we're going from left to right. So add them up in this direction. And then you'll do 4 minus whatever that number is. And that'll be f of 0. Okay, so you'll compute that. And then you'll have to repeat that process with whatever answer you had in the last problem. So you'll put your answer from the last problem here and here, and you'll run through that process again. And that's how you compute letter B. Actually, we're not done yet. The last thing is you'll have 3 numbers, right? You'll have f of a, which is your answer, your y value that's associated with your answer from letter A. You'll finish off my f of 0, and you'll have a y value there, and then you'll have the 4, and you pick the lowest one. The lowest one is going to be our absolute minimum. We just list those y values, pick the lowest one, and that's the absolute minimum. Okay, those are my hints for letter B. We'll get a clean slate, and we'll move on to letter C. Test. All right, so here we go. Sorry about that. My microphone stopped working for a minute. We said on this slide we were going to talk about letter C, so let's do that. Letter C is down here. We are asked to find on what open intervals contained in 0, 8 is the graph of f both concave down and increasing. So again, we're talking about f, not f prime. Okay, how do we find out when f is concave down? Well, we look for where the second derivative of x is less than 0. Intervals where the second derivative is less than 0. And how do we find out when f is increasing? We look for where the first derivative is positive. Let me get rid of this equal sign. We just want less than there. Okay, so we are going to answer this question by finding out where both of these are true, where the first derivative is positive and where the second derivative is negative. Okay, remember, this is the graph of f prime. So how do you find out where that thing's positive? Well, that piece is just find the parts of the graph that are above the x-axis. So the first thing we're going to look for is where is this thing above the x-axis? And then for the second derivative, that would be the derivative of the first derivative. And since we're looking at the first derivative, to find the derivative of this graph, which would be the second derivative, we look for the slopes. So for the second derivative, we look at this graph and find out where the slope is down or decreasing. So to answer letter C, your hint is look at this graph, and we're looking for places where it's above the x-axis and where the slope is negative. And you'll just write down those intervals, whatever they happen to be, okay? Use your interval notation to do that. They're open intervals, so you're going to put parentheses in instead of square brackets. And when it says explain your reasoning, please write down, hey, the graph is above the x-axis, and we're talking about the graph of f prime right now, the one that's pictured. The graph of f prime is above the x-axis, and the slope is negative in these intervals. Those are my hints. See what you can do with that. And then we'll talk on Monday. Let's do letter D on the last slide, and then we'll wrap this video up. Okay, microphone's still working. I guess that's good news. Let's focus on letter D here. We're making a new function called g. and g of x is f of x cubed. So it's the whole thing cubed. If f of 3 is negative 5 over 2, find the slope of the line tangent to the graph of g at x equals 3. So they are asking us to find g prime at x equals 3. So we'll put a 3 in there. This is what we're looking for, g prime at x equals 3. So what in the world does that mean? Well, the derivative of g of x, so let's do g prime of x, is going to be the derivative of the whole f of x thing's cubed. So let's run through and do the derivative of that. That's going to be a power rule, so that's going to be 3 times times f of x, times f of x squared. Right? That's our power rule. But then, because of the chain rule, we got to multiply by f prime of x. And we're going to plug 3 into that mess. So our calculation is really going to be, because remember, we want the slope at 3, right? We want the slope of the tangent line at 3, so that's the derivative with 3 plugged in. So we want, so g prime of 3 is going to be 3 times whatever f of 3 is, and then we square it, and then times f prime of 3. Okay, so I did the heavy lifting for you here, and now you ought to be able to find what f of 3 is. I'll give you a hint. They already told us what it was in letter D. And you ought to be able to find f prime of 3 because it's on the stinking picture somewhere. Okay? So I'm not going to say any more about that right now, but you plug those numbers in and you finish this thing off. Okay? So this video was filled with hints to help you get through this free response problem. This is our first go this year at a free response problem, so I'm giving you lots of hints, and then as we begin to practice more, we'll let you do more on your own. I hope this helps. Come back with questions. You know where to find me. In the meantime, you guys take care.